Hey Rams, it's Ms. Morrow. We are going to work through your homework for Tuesday, April 27th. This is on page 19 and 20 in your STAR Review booklet. All right, number one is kind of a tricky problem here. It says figure ABCD is similar to figure WXYZ. Which proportion must be true for these figures? So when I work through this problem, I set it up and I give these side lengths different names. Like I could call this the short side and this one the long side. Okay, on this parallelogram though, it looks a little different. The short side is actually the top and bottom, and the long side is the left and right. So when we set this up, what we would either need to see is comparing the two short sides like that, and then long sides where maybe the top row represents the small parallelogram and the bottom row is the large parallelogram. Or we could switch it where we just have the left and right are these small and large parallelograms. So we might compare the short side to the long side on the small parallelogram here, and then the short one to the long side over here. Either of these would work as long as on this one, looking across at different shapes, and this one, each shape has its own column, okay? So in this case, answer choice A says side length AB, so we're looking at short side here, compared to BC, which is a long side, is going to be equivalent to ZW. Oh, that's a long side there, over WZ. Wait, ZW and WZ, that's the same side length. Wait a minute, you can't use that. Okay, B says line segment BD. Oh, wait a minute, that goes across the middle here. That's not even one we could use. Okay, we're going to skip that. Let's jump down here to D. D says line segment DA, which is the long side, compared to ZY. Uh-oh, that's a short side. And then we're going to compare line segment CD, right here, that's a short side, to XY, and that's a long side. So do you notice how if I have the long side at the top of the ratio, then over here on the right side, the long measurement must be on the top of the ratio. So I can't flip these. All right, C is a little bit tricky here because what it actually has is short side and short side of the same shape, and then short side and short side. So honestly, I would, to prove that they are proportional, you would have to have your other dimension in there because these two short sides that we're comparing are congruent, but all of the others are completely wrong. So this would be the one that's correct. Number 2, which of these best describes D, the diameter of a circle? Okay, so remember when you learned about circles, circumference is pi times diameter. So which of these would make sense? Diameter, so if we start with D, remember when you're solving two-step equations, if I want to isolate the variable here, I can divide by pi because they're multiplied, and I'm left with D equals circumference over pi. Diameter equals circumference over pi. So the answer here is diameter is the ratio of the circumference of a circle to pi. Okay, diameter is not 3.14. In fact, circumference is not even exactly 3.14, and neither is pi because it continues on. Okay, it says diameter is the ratio of the diameter to pi. Wait a minute. Diameter can't be the ratio of diameter to pi. It's going to be something else, okay? And diameter is the square of the circumference. So circumference squared, we've never actually squared the circumference for anything. Okay, so that answer is A. That's number 2. Number 3, Micah made a scale model of the Empire State Building. The building has an actual height, okay, I'm going to underline that, of 381 meters. Micah's model used the scale in which 1 centimeter represents 50 meters. I'm going to highlight that one. That is my given ratio. Okay, what is the height of the model? So the two things I'm going to compare are the model height and the actual size. Okay, my given ratio is the first thing that I put. Just in any ratio table I ever use, if I have a given ratio, that's the first column. So in my model, 1 centimeter in the model represents 50 meters of actual height. So now the building has an actual height of 381 meters. All right, so I have to figure out, well, I don't know how many times 50 goes into 381, right? But what I can do is say I do know how many times 1 goes into 50. Okay, if I'm trying to get from the bottom number to the top number here, how do I get from 50 to 1? I divide by 50. So guess what I can do over here on the right side? I can also divide by 50. Just remember those patterns. So 381 divided by 50 gives me 7.62. 7 62 hundredths. Okay, that's number 3. Number 4, triangle JKL is similar to triangle MNO. What is the perimeter of triangle MNO? So it's really easy to look at a problem like this and just assume that we are solving for X. But we're not. We have to find X, but then we have to take it one step farther to find that perimeter. Okay? So I know if I'm looking at these two triangles here, I know I'm looking for the base of it somewhere. Okay, let's go with the left side. I'm going to compare the left side and the base. Okay, so this one right here, left side is 6, and the base of this one is 15. The left side of this one is 4, and the base is X. All right, so now I can cross multiply and divide. 15 times 4 is 60. And then I'm going to divide by the other number that's left over. 60 divided by 6 is 10. Now that is not my answer. That is the length of this side right here. The question says, what is the perimeter? Well, remember, perimeter is all of your sides added up. What is the distance all the way around it? So 4 plus 6 plus 10 equals 20. That is my perimeter. 20 inches. All right, question 5. Figure ABC is similar to figure XYZ. What is the value of X in meters? All right, so these similar figures are great, but they are rotated differently. So I'm going to try to redraw this one so that it matches the way this one is sitting. So if I did that, it would look like this. If I think about where my right angle is, my right angle is Y, and then X would be the bottom, and Z would be the top. Okay, so my base right there by that right angle, it would be a 2, and this diagonal across from your right angle, we would call that the hypotenuse. That's actually an 8th grade word, but it would be the 5 right over here. Okay, so the two things I'm going to compare are the base and the diagonal. I'm just going to set up my ratio table just like always. So the base of this one, we're going to call it X, and the diagonal is 25. The base of this one is 2, and the diagonal is 5. And if I want to figure out what the X is, I could look at it a couple of ways. I could cross multiply and divide. So I get 50 divided by 5, or I can say, well, I know that 5 times 5, not divided by, 5 times 5 is 25. So 2 times 5, going that direction, would be 10. So that answer is 10 meters. All right, just a few problems left on this homework. Number 6, the rectangle below is dilated by a scale factor of 3.6 to create a new rectangle. So remember, scale factor is what you multiply by to get your new dimensions. If scale factor is larger than 1, your picture is getting larger. If your scale factor is smaller than 1, it's getting smaller. So my scale factor is 3.6. That means my picture is going to get bigger. Okay, so really all I have to do is multiply every side by 3.6. Now, 4 times 3.6 was 14.4. That one's pretty easy. But I do not know how to multiply a fraction times a decimal. What I do know how to do is multiply a decimal times a decimal. So if I make that 1.5, 1.5. Oh. And I multiply it by 3.6, my answer there is 5.4. So these are my dimensions. And there we go. The answer is A. Okay, number 7. Which of the following is not a true statement about pi? So when I see problems like this that have like not a true statement, I go read each statement and I put a T or an F beside each problem to help me remember what I'm looking for. Okay? All right, so pi, the ratio of circumference to diameter. Okay, we learned that circumference is pi times diameter. Okay, but yeah, it is comparing the circumference to diameter, right? Because pi is diameter divided by, circumference divided by diameter. Okay, so A is true. Okay, is it approximately 3.14? Yes. We sometimes just call it 3, but that is one of those irrational numbers that goes on forever. So we just estimate it to be about 3.14. Okay, is it also approximated to be 22 over 7? 22 sevenths? It is. Sometimes, very rarely, but sometimes we see a problem that just says, assume that pi is 22 over 7. But if you did that, you'd get about 3.14 anyway. Okay. D says, the ratio of the radius to its circumference. Wait. Radius. Okay, so circumference we knew was 2 pi r. So if I wanted to consider that, if I wanted to find pi in terms of radius, it would be pi equals circumference divided by 2 times your radius. So it can't be just the ratio of radius to circumference because we forgot about that 2 in there, right? We can't just ignore that. So D is the one that is false. It's not true. All right, last problem here. Figure ABCDE is similar to figure LMNOP. What is the value of P in inches? All right, so I'm looking right here. P, if I look at this picture as like a house, if you rotate your paper and look at it like a house, this is the left side of the roof. So if I took this ABCDE, which side corresponds to that? The left side of the roof would be AE, line segment AE. Okay, so I'm going to call that left roof even. You could call it by the line segments. You could say line segment PL, but man, I make it easy. I'm going to say left roof, and let's compare the right roof. Because if I can turn this upright and see it as the left and right side of a roof, I am not going to get as mixed up in finding the two pieces that are corresponding. Okay, so let's go with the small shape here and the bigger shape here. Those just little symbols help me figure out what I'm looking at, okay? So the left roof of the small shape is a P. The right roof of the left roof of the small shape. Actually, I'm going to put my small shape here and the large shape up here. Sorry, I wrote those in the wrong spot. Okay, now the right side of the roof of the small shape is a 9. Okay, and the big shape up here, the left side is an 8. The right side is a 12. So to solve this, you could cross multiply and divide. That would be exactly what I would recommend because there's not a nice, easy scale factor between these numbers. But 9 times 8 is 72, and 72 divided by 12 is 6. So the answer would be 6 inches. All right, that is the last problem on tonight's homework. Make for sure you have all the work shown before you get to class tomorrow, okay? Have a good night, Rams.